Good afternoon, everyone. I'm Patrick Cummins. I'm the Executive Director for the Connecticut Audubon Society. Welcome to Young, Gifted, and Wild About Birds. This is the second of 5 presentations we have planned for 2022. Today, we're going to hear from Sam Apgar. Sam is a Ph.D. candidate at the University of Connecticut, where she works with her advisor, Dr. Chris Elphick of UConn's Ecology and Evolutionary Biology Department. She's working on her dissertation at the moment now and plans to finish by the end of the summer. You might remember her from the article in our 2020 Connecticut State of the Birds about how the pandemic affected her fieldwork. Last week, we heard from Dr. Brooke Bateman, who gave an important overview on the topic of climate change and Connecticut's birds. Sam's talk will focus on our 4 species that are being affected by climate change already, and perhaps the worst. Her presentation is entitled High Tide for Saltmarsh Birds. Before she starts, a few notes. We are recording the presentation today, and we'll send you a link to the video, including anybody who couldn't make it. Everyone will be muted throughout the presentation to prevent background noise. We recommend that you use the speaker view for the best presentation experience. You can select that view in the upper right-hand corner of your screen. Use the chat function to ask questions. Closed captioning will be activated, but you can turn it off if you prefer. And now let's hear from soon-to-be Dr. Sam Apgar.
Thanks so much for that introduction. And thank you everyone for coming to listen to me today. I'm very excited to speak with you all. Okay. So today I'm going to be talking all about my dissertation work and what I've been finding so far. What I've been finding out so far about these marsh birds. So at the outset of this talk, I'd like to say that no research is done in a vacuum. There are a lot of different groups that have supported my work, either financially or in terms of allowing me site access to do my work, collect my data, and in terms of field crews, undergraduate volunteers, and independent study students who have helped me collect the data and analyze the data. I'd also like to reference the Saltmarsh Habitat and Avian Research Program. This is a group of researchers at a number of different universities, professors, undergraduate graduate students, and postdocs who have been working in marshes for a long time. And I'll be talking about some overarching findings from this group in the beginning, and then moving on to some findings from my work specifically. So let's talk about tidal marshes. So tidal marshes are these ecosystems that are found kind of on the interface between ocean or bay and further upland environments. And being in Connecticut, you've probably seen some before. So tidal marshes are pretty homogeneous in terms of their vegetation. There are different species of grasses, but it's mostly dominated by grasses. You don't see a lot of shrubs or a lot of trees in the interior of marshes. Another really important thing about tidal marshes is that they are tidal. So you have 2 high tides and 2 low tides every day, and you have higher high tides around the new or full moons. So the degree to which the marsh floods is dictated by a lot of factors, but the moon really dictates it quite a lot. So if you're a bird that's nesting in this environment, your nest is inevitably going to be placed in the grasses pretty close to the ground. So this is a clapper rail nest, and it's nice and dry. But again, since marshes are tidal, if you're putting your nest near the ground, it's going to get wet sometimes. So here's that same clapper rail nest underwater during a high tide event that happened probably about 6 hours after the photo on the left. But even though this seems pretty intense, these birds have been dealing with these conditions for a long time. These species have been living and reproducing in marshes for thousands of years. So they have some tools to deal with some amount of nest flooding. But you've probably or hopefully heard a little bit about the Saltmarsh Sparrow. So the Saltmarsh Sparrow is one of these species that nests in tidal marshes. And unfortunately, they're declining pretty rapidly because of largely sea level rise plus some other historical factors. So how do we know that the Saltmarsh sparrow is declining? So SHARP, the Saltmarsh Habitat and Avian Research Program, some of their earlier studies started with doing this massive survey effort where at all of these points, locations on the coast from Maine down to Virginia, they went out and surveyed for tidal marsh birds. So all of the birds they could hear or see, they would record, and they compared this data from around the early 2010s to data from the 90s. And they found that overall, specialist tidal marsh birds are declining in their abundance. So this plot shows year on the x-axis going from the late 90s to 2012. And on the y-axis, you have specialist relative abundance, which basically means these species that are living and breeding in marshes pretty exclusively, how many of them are around. And you can see that line is showing that they've been declining over time. And the Saltmarsh sparrow is declining specifically at a rate of 9% per year, which is the greatest decline out of all of the species that were studied.
Bring in some cold water, please.
In terms of further demographic work. So they're declining, but why is that? So to study that, we have a subset of points, 23 sites across the coast where Saltmarsh sparrows breed from Maine down to Virginia, where we would go out and find nests and monitor them, determine whether they failed or fledged and why they failed if they did. And largely it was found, unfortunately, that Saltmarsh sparrows are not able to fledge enough chicks because of nest flooding, either eggs flooding out during the egg stage or chicks drowning during the chick stage and not being able to get out of the nest successfully before the high tides start rising associated with the moon. And then we've projected that out into the future as well. And extinction is probable for this species. But back to my dissertation is what I was thinking is we know that these species are all declining overall, but some of them aren't. So going back to this trend data, the Saltmarsh sparrow is declining at a rate of 9% per year. The Seaside Sparrow is actually exhibiting stable population trends according to those point count surveys that I just spoke about. Nelson sparrows, further north of here, are declining at a rate of 4.2% per year. Willets, also exhibiting stable population trends. And then finally, clapper rails are declining at a rate of 4.6% per year. So the crux of my dissertation is the Saltmarsh sparrow is feeling the effects of sea level rise the strongest, but some of these species are, the other species are declining less rapidly or not at all. So why is this? If they're all dealing with the same stressor, nest flooding associated now more so with sea level rise, why are we seeing these different trends? Do they have different life history traits that help them or hinder them in respect to increased nest flooding? So I've been studying this with 4 species, all found in coastal Connecticut. So Saltmarsh sparrows, Seaside sparrows, willets, and clapper rails. And the first thing I wanted to understand was during these flooding events that happen predominantly at night when the tide's really high, how do these birds behaviorally respond to these nest flooding events? And do any of the behaviors that they exhibit impact the fates of their nests on those high tide nights? Meaning, do the birds do anything that prevents eggs from flooding out of nests or chicks from drowning? So I used infrared cameras to study this phenomenon. So what I did is I found a bunch of nests at 2 sites in coastal Connecticut, Hammonasset Beach State Park and East River. I put out video cameras on all of the nests that I purchased from this adorable ghost hunting website. They actually had the best cameras I could find for studying this particular problem, because during my PhD, the highest high tides occurred during the new moon when there is a total absence of lunar light. So I had to film in complete darkness. And what I got was a whole bunch of videos, over 400 hours of videos of saltmarsh birds during these flooding events. And sometimes their nests wouldn't flood as well, even though the tides were higher on that night. So I'm going to be showing some videos, and just to orient you, they are going to look like this, kind of purpley and a bit dark, but I'll point out important features, i.e. in this photo, you can see there's a bird right there. It's a Saltmarsh Sparrow, and there's a nest in front of it. So jumping right into some immediate results. So this plot shows on the x-axis, the total time nests were wet in minutes, and on the y-axis, the different species I studied. So the main takeaway here is that these nests are all getting wet for pretty similar amounts of time across the species, and they are very variable in terms of how long they're wet for. So this data point right here in red is the smallest amount of time a nest was wet for just about 7 minutes, and it was a Saltmarsh Sparrow nest. And then this data point over here was a Saltmarsh Sparrow nest that was wet for over 4 hours. So that's a lot of time. Okay, so jumping into how do adults respond to nest flooding. So I'm going to start by showing a video. So in this video, you'll see there's the nest right here. It's actually got a little bit of water in it and 4 eggs. And you're going to see a Saltmarsh Sparrow emerge from the bottom right of this video and go into the nest and then exit. So coming from the bottom right of the screen, we have a Saltmarsh Sparrow come into the nest. The nest is a little wet right now. It kind of stamps around, and then it decides to leave. So in looking at what these species do during flooding events, and specifically the Saltmarsh Sparrow. So this data shows nest age in days on the x-axis and the proportion of time that adult Saltmarsh Sparrows were incubating the nest contents when the nest was wet. And so the takeaway here is that line is pretty low. The proportion is pretty low in terms of how much time they're incubating when nests are wet, and it's pretty consistent across the age of the nest, so whether the nest is younger or older. This yellow line denotes the proportion of time they incubate nest contents when the nest is dry. So on high tide nights, except for nests that didn't wind up getting wet. And you can see that earlier on, they spent a lot more time incubating because that line is higher when the nest is younger. But then towards the end, when the nest is older and you have chicks, which is represented by this purple line when chicks first start in the nest, then after that, they're pretty much not incubating much at all, whether the nest is wet or not. But overall for this species, they're really not spending a ton of time at nests at night, whether they're wet or not actually. Okay, so moving on to another species. This is a willet nest. So we've got 3 willet eggs in the center here, and you're going to see the water just come right up on this willet nest. And this is a sped up video, so this is not real time. So we see the water coming up. The eggs are floating with the water. One of the eggs is actually floating kind of outside of the nest cup area. Now kind of 2 of them are. And so this video is kind of emblematic for a lot of the species, but specifically for willets, they're really not spending much time at all at nests when they're flooding. Clapper rails, on the other hand, do spend a little bit more time than the other species at nests when they're flooding, not more time than when they're dry, but they also do some more interesting things than the other species. So this video is going to show a clapper rail in a nest that's wet, and it's using its bill to move around vegetation. So this circle represents the nest. We're pretty close up into the nest. There is a clapper rail adult denoted by this arrow, and the nest has some water, and it's going to use its bill to move around blades of grass. So it's taking its bill, it's picking up blades of grass and moving them around in the nest. And this is a pretty clapper rail-y kind of trait. There have been other studies showing that these birds will move around vegetation and what's thought to be elevating the height of the nest, or I think just keeping it well structured so the eggs aren't flooding out. And they can even go and retrieve eggs that have flooded out of nests, although I didn't capture that on any of my videos. Okay, so we just talked about adults for a little while. We're going to move on to talking about nestlings. So this is about this next question is, what is Saltmarsh Sparrow nestling climbing impacted by? So Saltmarsh Sparrow and Seaside Sparrow nestlings spend about 8 to 10 days in the nest after they hatch, before they leave the nest. And when they're older, they're capable of actually climbing up on vegetation to wait out a high tide and then climbing back in the nest. And we knew that this happened, but we didn't know how much and what impacted it, which I was able to determine with my videos. So just showing what this behavior looks like. You have a nest here. It's got a woven nest canopy on it. So there's vegetation completely covering the nest cup. So right now you can't see the interior of the nest, but that's where it is. And then what you're going to see is chicks from inside the nest climb up onto the top of that nest dome, denoted by that smaller circle. And this video is sped up and it happens pretty quickly. So I think I'm going to play it twice so you can see what's happening. So this was over maybe a 10-minute period. Already see a chick has climbed up vertically up onto the top of that nest dome. And now another one's going to climb up and join it. So let's play that one more time. So again, there's water. It's a little hard to see, but there's water on the surface of the marsh, and that's driving those chicks to climb directly up the nest cup and sit on top of the nest cup. So what we found when we did some modeling of this is that chicks that are older will climb up, but they'll climb on lower high tides. So this plot is showing whether a chick climbed, yes or no, on the x-axis, and then how old the chick was. So really closer to 7 or 8 days, we're seeing chicks climb up vegetation. But again, really importantly, they're not climbing on really high tides. They're climbing on lower high tides, which is pretty important, showing some sort of that climbing up vegetation isn't always going to be an option when tides are really, really high. Okay, now this is the most important question of this research. Does any of this behavior matter in terms of nest fates on high tide nights? So do the birds doing anything impact whether the eggs or the chicks fail or succeed and continue on? So this is data that's kind of emblematic for just the Saltmarsh sparrow. So this plot on the left is just during the egg stage, and the x-axis shows the number of offspring lost, so the number of eggs lost on a high tide night, and the y-axis shows high tide height. So you can see that this line goes from a lower value to curving upward. So really what's driving Saltmarsh sparrow egg loss on high tide nights is not anything the birds are doing, but actually the high tide height alone. And this same trend, unfortunately, is the case for during the chick stage. So on the right, we have the same type of plot, number of offspring lost, but for chicks, and a high tide height on the y-axis. And even though the chicks have this ability to climb, as I showed in my other model, they're not climbing on higher high tide nights. I think the tide's just too high. So even during the chick stage, tide height is driving the number of offspring lost. For the other species as well, there aren't as strong trends as for the Saltmarsh sparrow, but really the adult birds aren't doing anything that's making them lose fewer offspring on high tide nights either. Okay, so then a next logical question from this is, okay, what factors influence how much a bird's nest floods? Maybe these species nests flood at different rates that could impact how they're doing. So what I did was I took my videos and I classified them in terms of how much each nest flooded on a high tide night. So whether they didn't flood at all, no water category, whether they flooded a little bit, so the water came in, but it didn't fully cover the contents. So in that picture, there's a little bit of water, but it's not fully covering the eggs. And then finally, water fully covers the nest contents. So in this picture, you can see that the eggs are actually up and floating completely above the cup of the nest. And then I wanted to understand what factors influence these three different amounts that nests could flood. So the factors I included in my models were how high the nest was off the ground, what part of the marsh it was in. So different parts of the marsh tend to flood with different frequencies. So this area of the marsh denoted by this white circle is called the high marsh zone. It tends to be dominated by one species of grass that just doesn't tend to flood as often, versus the low marsh, this other main area that tends to flood more often. How high the tide height was. So I incorporated tide height into these models. And then finally, elevation. So does the raw elevation of where nests are impact how much they flood? And unfortunately, again, tide height is really driving this trend. So on the x-axis, we have tide height in meters, and in the y-axis, we have these three different categories of how much the nest flooded. So on the bottom, you have no water in the nest. So that happens on tides that tend to be lower. When water partially covers the nest contents, that happens on slightly higher tides. And finally, the topmost row, when water covers the nest contents completely, that's on really high tides. And those other factors, elevation, where you are in the marsh, your nest height, didn't affect this trend as much as tide height alone. Okay, so moving on, another question in terms of where the birds put their nests in the marsh. So I want to understand where and how they put their nests in the marsh, because maybe that affects flooding. The results I just showed you are showing that that might not matter a ton, but it might matter for other things. And my sample sizes were also kind of small for that. So where you put your nest could matter still. So how am I studying that? I have my two sites, Hammonasset Beach State Park and East River. And you can see maps here of these two sites, and all of these red dots correspond to nests that I found. I also went out and collected data at random points in the marsh. So these yellow dots all represent random places in the marsh where I collected the same sorts of data as at the nests. Because in this framework, I can compare the nest data to the random point data and get an idea of how birds select where they put their nests relative to the available conditions. So at each of these points, the nest points and the random points, we put out 1 meter squared quadrats, and we measured a number of things at the midpoints of each side of the quadrat and at the center. So the things that we measured were the types of vegetation that were there. So again, whether the vegetation was more representative of that high marsh zone, where Spartina patens is the grass that tends to dominate, versus the low marsh zone that again floods more frequently and tends to be dominated by a grass species called Spartina alterniflora. I also incorporated measures of the average thatch layer. So thatch is dead vegetation from previous years that's mostly horizontal, and the average vegetation height at those points for the live vegetation. Again, I incorporated elevation across all of these locations. And then finally, I included how close a nest was to the closest tidally influenced waterway. So if you imagine that that dot is a nest, I measured the distance from the nests or the random points to the closest waterways. Unfortunately, I don't have those results ready to share for today. To be determined, I'm still working on those models, but I hope to share those results in the future. But I do have some other nest-related results I can share. A follow-up question in this chapter is, where and how do these different species structure their nests? So nest structure could be influential to how their nests flood, or how depredation impacts their nests as well. So what I did was I used the variables of nest height again, thatch height, the dead horizontal vegetation, and average live vegetation height, and the percent cover of vegetation over the top of a nest. So if you look immediately down at a nest, I put a white disc in there. This is a willet nest, and estimated how much vegetation was covering that disc. So what I did to study this is I created hypervolumes. So we're not going to dwell on this plot a little too much because it's a little overwhelming, but this is just to show you with this method, you can basically carve out across multiple variables the space that an organism is using, and you can see it in kind of a multidimensional fashion. So what the main results of this are showing is that the hypervolume, so the space that clapper rails are using in terms of their nest structure, is the largest across all of these species. So clapper rails have greater variation in these nest structure traits than seaside sparrows. Seaside sparrows have greater variation in these nest structure traits than saltmarsh sparrows. And then willets have the smallest variation in nest structure traits. And so to demonstrate that, you can look at just each hypervolume for these species. So the main takeaway here is clapper rails are on the top right and willets are on the bottom left. And you can see, if you look at the clapper rails, they're covering a pretty big area in terms of how much variation there is on these different axes within these different variables for what their nests are structured like. That basically means that they have nests that all vary a lot in terms of how they're structured. And as compared to willets on the bottom left, you can see the total volume of these, each of the different plots is a lot smaller compared to the clapper rails on the top right. And this basically means if you're a species in times of change, so global change, for example, with these species, sea level rise, we're tending to find that species that have a lot more variation in their traits tend to do better. So from these kinds of results, I can understand which species are a little bit better prepared, perhaps, in terms of the way they structure their nests. And then when I have the results from the first analyses, based on where they place their nests. So in this case, clapper rails have some good capacity in terms of how they structure their nests. So what is my work telling us so far? All species do not exhibit a lot of adaptive capacity in relation to behavior during nest flooding events. So all of that behavior work basically showed that these birds are not doing a ton of really interesting things when flooding events happen. Clapper rails definitely show the most in terms of adaptive capacity because they do move around eggs and adjust the structure of their nest during flooding events. However, they're not doing it at a greater rate than when nests are dry, and for the other species as well. But the most important takeaway was those plots at the end that show that even with birds doing different things, tide height is really driving how many offspring are lost on high tide nights. And even for the sparrow chicks, they're not climbing on higher high tide nights. Secondarily, species do differ in the variability of how they structure their nests. So despite these birds being in a pretty homogeneous habitat that all looks pretty similar, they are taking advantage of it in slightly different ways and to different degrees. And that can shape potentially some of the trends we're seeing in terms of their population trajectories. And finally, tide height is really emerging as an important feature in all of these analyses in terms of what's driving how these species respond to tide height, but then especially in terms of fate. So what does this mean? During my dissertation, I wanted to understand the adaptive capacity of these species, and I'm still working on analyses in some other different ways to understand this question. But what's coming out is a story that's pretty similar across climate change stories. These birds are adapted well to this really specific environment with this really specific challenge of water, and not just fresh water, but salt water. And they've done well dealing with that for thousands of years. But sea level rise from climate change is just happening really fast. And it's showing, my results are showing that they probably don't have the capacity to deal with it on their own. So this leads me to what I think is the most important thing, which is marsh restoration. So at the federal, state, and nonprofit levels, people are putting a whole lot of money and time at figuring out solutions to restore marshes to better deal with sea level rise. So there are a couple of different things that are currently being employed. One thing that's being employed is called thin layer deposition. At a number of marsh sites across the coast, practitioners are adding sediment to marshes to manually increase the height of the marsh platform relative to the sea level to try to get it to not flood it as much because it's higher up than it is currently, because marshes are not accreting sediment at the rate they should be to keep up with sea level rise. They're also doing other strategies called runneling, which is when you create ditches to drain off water that's pooled up on the marsh and is converting the marsh into mudflats. And then finally, those are some of the main methods, but we're still trying to experiment with more marsh restoration methods to try to deal with this massive problem, which is increased nest flooding, whereby marshes are flooding too often or converting in what sorts of vegetation are there, and we're losing marsh, the total extent of marsh over time. So with that, I'd like to say thanks so much for listening, and I'd be happy to take any questions about my research thus far.
Great, thank you so much, Sam.
Yeah.
We do have a couple of questions already. Tom is going to be reading the questions for you, and then we can discuss.
Sure. Hi, everyone. It's Tom Anderson. So the first question that came up early in your presentation, Sam, was from Bev, who wanted to know if you rescue the nestlings that you photograph when they're being flooded, or do you move the nest to higher ground?
That's a great question. So a couple of things. During a little more detail about how I collected the video data is I'd go out, put out the video cameras, and then I would actually leave the marsh. I put out about 10 cameras a night. I'd leave the marsh and hang out in my car outside of the marsh while the marsh flooded for a couple hours. And then I went back out and collected my camera data. So I wasn't actually immediately around them when the flooding was happening. And that's in part because I wanted to understand, I also wanted to understand what was happening without human influence. That being said, there are some strategies that are being employed and thrown around about whether we should be saving individual nestlings. So one thing I can speak to is some collaborators in Maine have tried employing methods where nests that are pretty low to the ground that are still active, they've added sediment below the nest to increase the height of individual nests. And they've had some success with that, where nests that probably would have flooded wound up fledging chicks. Another idea that's been thrown around is the idea of captive breeding. If it eventually got to the point where we're having really low population sizes, should we captively breed birds and re-release them into the environment? The sad part about all of these, though, is it's pretty hard. We want species to be able to take care of themselves, and it's pretty hard to save species one nest at a time. Which is why I'm hopeful for marsh-wide restoration tactics to make the marsh healthier so that they can actually do their thing, reproducing and living in marshes without directly interfering with them.
Mary Ellen LeMay asked about the possibility of putting nests on floating platforms. Did you ever hear of that?
Yeah, that's a great idea and question. So great minds think alike, I think, because that was one of my early dissertation ideas. I was talking with my advisor and I said, could we put some sort of, floating material below the nest and anchor it in so that, nests could just float upward. So yeah, I think that's definitely been an idea that's been thrown around and could be effective for a subset of nests. But again, the unfortunate part is it's really hard to save a species nest by nest. Yeah.
So here's a question from Sylvia Halkin, who is a Connecticut Audubon member. She was wondering why flooding tends to occur at night rather than during the day.
Yeah, that's a good question. So flooding does occur during the day. It's just that it happens the tides are even higher at night. You can actually pull, your local NOAA station data and see that the high tide heights during the day are a bit lower than at night. It kind of follows the cyclical pattern. But I actually don't know why that is. I can say that the moon has all sorts of complicated ways it pulls on and impacts tides. That's one of the ways, but I don't actually know beyond that what the reason is. So
Sylvia also asked, and this is something that occurred to me when I was looking at your maps. She says, "I'm so impressed you could find all those nests." And it
yes.
made me wonder, do you have help when you're doing it? How hard is it? And how long does it take to find those nests?
Yes. Awesome question. So I appreciate that. It was a lot of work. So I did, that data was all from 3 or 4 summers, I think 3 summers. And we cover pretty large areas. So again, it wasn't just me. I would have help, 1 to 2 technicians almost every day out there with me. And the way we would do it is we'd walk kind of transect lines, imaginary lines through the marsh back and forth. And we'd find the nests a little differently depending on what species it was. So Saltmarsh and Seaside Sparrows tend to be pretty cryptic about their nests. They're smaller and they tend to be hidden under pretty well in the ground. So you can either find them because you've seen a lot of nests and you kind of, I don't know, it's this weird sort of instinct. I find a lot of nests by just finding them on the ground, but you can also find them by the bird flying up and away from a certain area. And if it kind of darts down soon after, it's probably not going far because it just left a nest because it heard you coming. So you can kind of create a smaller area you search in until you find it. The willets are maybe the easiest because they'll stick tight on the ground and they're pretty big and they'll just explode out of the ground and give you a heart attack right in front of you. And then you look down and there's a nest. The rails you can often spot because they're pretty big nests. They're often close to ditches. And if you find them later on, they'll kind of get mad at you if you come upon it and then there's a nest right here. But then we leave them alone afterward. And yeah, so that's just to say kind of how we found them. We would be out nest searching every single day for 3 months in the summer, May through, well, maybe not every day, 5 to 6 days a week from May through August. And yeah, it was a lot of work, but it was a lot of fun too.
This one is for maybe Patrick as well as you, but you've been working at, you said, East River and Hamo. Mm-hmm. What are the other big marshes in Connecticut where you can find these species?
Yeah, that's a good question. I can jump quickly on just saying Barn Island Wildlife Management Area is also a good site to find these species. All 4 of them should also be there. And those are the 3 areas that I went to the most, but there should be some other sites as well. I don't know if Patrick wants to.
Grid is the biggest, but that one's so hard to access. Mm-hmm. That's at the mouth of the Connecticut. And there are Seaside Sparrows in Stratford and Milford, a few Saltmarsh Sparrows, but towards the western end of the state, the marshes tend to get a little bit more low marshy, Peyton's dominated. One exception potentially is Ash Creek in Fairfield. I recall they have a pretty decent population of Saltmarsh Sparrows, but East-West River, well, the biggest by far is Great Island, East-West River, and then Hammonasset, and East-West and Hamo are pretty close together. And then Barn Island is probably the 4th, And then there's one site that's really weird and really productive in eastern Connecticut. Maybe it's somewhere near Goshen Cove, but I'm afraid to get exactly where that was. But it was a spot you wouldn't expect to be a highly productive site, but it's a smaller site, but it ends up having the highest productivity of any of the sites in Connecticut. So it was a little odd.
Here's another question from Sylvia Halkin. She wants to know what actually kills the eggs, destroys the eggs, kills the nestling. Is it drowning, lack of oxygen, desertion, or getting too cold?
That's an excellent question. Yeah, that I didn't specify. So, so for the eggs, it's flooding out of the nest completely. Eggs can flood in the nest, but as long as they stay in there, they seemingly get enough oxygen, and the adult doesn't desert the nest and comes back and incubates. So there was an earlier study by my advisor and one of his graduate students where they used eye buttons, these little data temperature loggers. They put them in nests, and they found that for saltmarsh sparrows, their nests could get wet up to 9 times. And as long as the eggs didn't float out of the nest and the adults could incubate them, they could hatch into chicks and fledge. So really the temperature or lack of oxygen doesn't seem to be a problem for any of the species in terms of flooding. It's just if the eggs float up and out of the nest, then they're kind of donezo. Except for clapper rails, I don't have evidence of this, but other studies do that. They'll go out and manually pick up eggs and put them back in the nest and incubate them, which is pretty cool. In terms of the nestlings, so for the sparrows, they'll drown if the water comes up and over their heads. So they can survive, and they do survive getting wet just a little bit. They actually don't really seem to die from the cold or from getting wet, but it's really the drowning part, unfortunately. And I didn't talk about this much, but for the willets and clapper rails, their chicks hatch and they're pretty well feathered and developed. So they actually can move around and leave the nest within a couple hours to a day or two, which means that they're often not as at risk of drowning because they can swim around or climb up vegetation better.
Patrick, I'm going to direct this one to you. It's from Theo. She wants to know if tidal marsh land still faces development pressure, and are they more or less protected now than they used to be? That may be one that you can help us with.
I would say that they're probably similarly protected as they always have been. In terms of development of tidal marshes, it's not entirely off the table. There are certain uses that can happen. Recreational uses are a big threat when you talk about bikeways and things like that. Often those, for example, there's a bikeway that people wanted to put right across the bulk of the East River Marsh. And it would be like a platform, and sort of like you see this. Well, it's mostly on moraine lines in the marshes, like at Hamo, but it's not often that in Connecticut, because our salt marshes are so small, that we have these boardwalks that go out through a marsh. At Hamo, you used to be able to find saltmarsh sparrows from that little boardwalk that went from the parking areas over to the Meigs Point changing rooms, but they aren't in that little marsh anymore. So in some cases, those little outcroppings into the marsh are great places to see them. At Stratford Great Meadows, you can kind of walk out on some levees for now out into an area to get closer to where they are. But water dependent uses sometimes can get special permits to convert tidal marsh into other habitats. That is, marinas and things like that. It's not easy. There's a lot of Army Corps permitting required. There's a lot of state permitting required. So I don't consider marshes 100% protected. And then there's also, the public good things like, for example, there's going to be rebuilding of a railroad bridge in Old Saybrook to Old Lyme. And that's going to take up a certain acreage of habitat from Great Island. I think it's mostly Phragmites encroached habitat, but as part of the permitting process Fish and Wildlife Service is very interested in this species. Army Corps, therefore, is also very interested in this species. And of course, the state is as well. So they'll likely be looking at it. All right, well, what exactly sort of tidal marsh habitat is being impacted by any construction of the rail bridge that might impact Great Island? And then, to minimize, mitigate, and or do an in lieu fee sort of situation so that there's no net negative loss of the most sensitive habitat, which is the high marsh. Now, that all being said, to make it even more complicated, it's only legal protection. So it's only as powerful as the next Congress. Well, it is mostly federal protection, but there are state protections. So the next, Connecticut General Assembly, and of course, the next state or federal Supreme Court ruling. So, one could and has, people have made the argument that by the government coming in and saying your salt marsh is undevelopable, it's sort of an uncompensated take of your land, that all of a sudden your land values are lower because you can do less from it, which is something difficult for governments to do. At this point, those tidal marsh laws are old enough where most people have acquired their tidal marsh at a significant enough discount that it's kind of almost a laughable argument to say that the law is reducing the value of their lands, but there are some landowners who still try that argument. So I do have my three worries are water dependent uses, recreation, and potential changes to the law and challenges to the law, because that's four.
Terrific, thank you. Sam, a question from Donna Hansen, who is a member and she's one of our Osprey Nation stewards. She wonders, how is your work compared with other scientists along the coastlines in New England? I think what she means by that is, how do your results compare to the results that other scientists might be getting in salt marshes?
Yeah, so the specific things I've looked at haven't really been looked at exactly in the same way. But I'd say that, for a lot of the studies with marshes and flooding is that, it's a similar story of tide height really driving a lot of things, that marshes are getting too wet too often. One sort of related behavioral study from one of our collaborators in Maine, she looked at how the saltmarsh sparrows, how they change where they put their next nest and how they structure their next nest if their first one fails, and whether that is different depending on whether the first nest failed from depredation or from flooding. So there's a trade-off between the two. I talked a lot about flooding, of course, but nests that are lower to the ground, she found are often flooded. And then if they fail from flooding, the birds place the second nest higher up in the ground. But bird nests, saltmarsh sparrow nests that were higher up in the ground first failed more often from depredation. And so they placed their second nest lower down. So there's definitely a trade-off. In terms of, let's see, other things in terms of where birds are putting their nests, a lot of things, I'm still working on those analyses, but the results will probably be pretty consistent with other things that have been found for species individually. Yeah, it's kind of a roundabout answer, but.
Great. So
I can go back. I can go back a little bit to the key sites. I've been looking into some of the names again. As Sam mentioned, Barn Island is pretty key. There are a bunch of small marshes between Stonington and, say, Niantic that are in aggregate fairly important, but small numbers in each of them. Niantic, we get into that marsh. It's the Patagonia marshes. That's where the highest productivity is. It's near Rocky Neck State Park. It's just east of Rocky Neck State Park. Rocky Neck State Park's a relatively minor site for saltmarsh sparrows. Then we get to the Great Island and the mouth of the Connecticut River there, where there's habitat on both sides of the river. And particularly, well, Great Island is really important, but interestingly, saltmarsh sparrows have been documented as far north as Lord's Cove, which is north of 95 here. So in some ways, Connecticut River is very important because A, it gets a lot of sediment load, and particularly with the dynamics and physics of the sediment there, it allows the marshes to keep up a little bit. But B, it also has that inland migration capability that other places don't. The old Saybrook marshes in toto are very important. One I forgot about is the Westbrook marshes, the Mononchatisic. That is a great habitat for Saltmarsh sparrows and has been for a long time. Again, we get to the Hamo and Hammock marshes, the east-west river marshes we've talked a lot about. One area that I forgot that is fairly major is the Quinnipiac River tidal marsh, which is fairly inland. And then we get into more into less favorable conditions as we head west, and the Milford and Stratford marshes are pretty, barren of Saltmarsh sparrows, at least, until you get down to again the Ash Creek area.
Great. So here's a question from Matt Bell, who works in our eco travel office and also runs our rare bird alert. Matt wants to know, what's the renesting probability of these species if their nests flood? Are they one and done? Do they attempt to nest again if it's not too late? And is there a difference between the two sparrow species and the rail and the willet?
Yeah, that's a good question. So I guess starting with the sparrows first, starting with the Saltmarsh sparrow first, they actually have really fast renesting rates. So they do renest and they renest really fast. So they wind up actually, because of this, sinking with the high tides often. So you'll have nests starting up in May, a high tide event will come through and kind of knock out all the nests, and they'll really quickly, within a couple of days, start renesting. So you wind up having ideally chicks fledging right before the next round of high tides about a month later. Seaside sparrows, we think, are a little bit less synced with the tides, but they will also renest throughout the season. The birds will renest for the sparrows both into August, at least in Connecticut, but really tapering off towards the end of July. Clapper rails and willets will also renest, I'm pretty sure. Their windows are a little bit less long than the Saltmarsh and Seaside sparrows. Willets and rails both start up nesting a little bit earlier in May in Connecticut, and they tend to finish more earlier in July, though I've had clapper rail nests last into August as well.
The thing about sparrows is sparrows will typically, almost all sparrows, New World sparrows, will typically renest as many times as they can, even if they're successful. That's true of grasshopper sparrows, savanna sparrows. I assume it's true of some of the sparrows of lesser conservation concern as well, like song and swamp and et cetera. But Saltmarsh sparrows actually are the most promiscuous species of bird on Earth. And that came out of UConn's research as well. And what they do is they arrive, they asynchronously nest as soon as they get back. So the earliest ones back have the highest chances, but almost invariably all those nests flood out. And then instantly it's synchronized nesting where they almost all lay their eggs at the exact same time after that spring tide flood event. And we think that there may be a situation going on where the males kind of all just hang out in one place. The males take no part in raising or anything to do with nest care. The males may just hang out in a totally different place from the females. That's my hypothesis. It's an untested hypothesis shared by some other researchers, but I don't believe it's been fully confirmed. But it's sort of like a lekking situation where the females know where all the males are. When they have the need to re-nest, they go over there, then they come back and nest. So it's almost like they're two different species biology-wise, because the males aren't tied to a nest.
Only a couple more here. We're coming up on an hour, not quite. We got a little bit more time, but Hope asks a question that I think you might have referred to in your presentation. She wants to know if there's an irrigation or dam method that can be developed to control the amount of water flow to the marsh areas.
Yeah, so I didn't actually touch on that too much, but that is one of the options that are being tried at some marshes, which is if you have a tide gate that can modify how much water is getting in during those really, really high tide events to try to dampen it so that nests aren't getting completely washed out. the hard part is that that can work at some sites depending on the topography, the how it's set up, where it is. It's based on a lot of factors, but yeah, that is being potentially tried out some areas, or could be. And then I spoke a little bit about getting water off the nest continually with water that's been pulled up there by putting in a ditch. Yeah.
Yeah, and there's all sorts of stuff being looked at with regard to this species in particular. Some people are looking into the effects of natural channels, the meandering channels through the marshes, as opposed to the dug mosquito ditches. And what happens with those is it turns out you get these sediment levees that build on either side of those that end up being really good habitat for saltmarsh sparrows. So that's one thing that folks are looking into. The tide gate question is another one. It's a really thin balancing act, a matter of like inches between Spartina alterniflora, Spartina patens and Phragmites. So that's one thing, is that some of these high tide events help to limit Phragmites. Obviously, you can let that happen off season, but often you also get into situations where there's cross purposes between the DOT and your marsh, and you got the marsh gates in there and the neighboring properties as well, and they'll want you to cut them off for the ones that you don't want to cut off, and they'll want you to not cut off the ones that you do want to cut off. So it is something that they're looking at. I would love to see the entire New York coastal bight ringed in a giant barrier chain of high marsh habitat. But that might be a little ambitious. It would really help with coastal resilience as well. You wouldn't believe how good marsh grasses are at preventing coastal erosion. It's really as far as I can tell, marsh grasses are the best way to prevent coastal erosion. Dune grasses are good too, but marsh grasses just really suck up the sediment. And once you get marsh grass growing in an area, not only does your erosion stop, it actually starts accreting.
I have a question. Sam, you mentioned the SHARP project is working essentially from Maine to Virginia, I think you said.
Mm-hmm.
Where within that area are the largest concentrations of these birds?
Yeah, that's a great question. For Saltmarsh sparrows, it's definitely New Jersey. New Jersey hosts the largest amount of the population, both by how big the state is, but also because the marshes are just a lot bigger there. Marshes tend to become smaller as you go further north, just a lot more narrow. And also, interestingly, in New Jersey, the factors are a little bit different. Nests flood less there and actually are depredated more, whereas for the rest of the range, flooding tends to be the bigger issue.
Is that ghost crabs?
Say that again?
Ghost crabs getting them there, or?
Oh, well, we actually are not super sure what the depredation causes are. It's kind of hard to study depredation. Like what are the agents causing, what sorts of organisms are causing it with these species? Because in a forest, you can put up a camera trap on a nest, to take pictures when a depredation event happens. It's harder, in a marsh, there's no, even putting my video cameras out, I was a little worried about increasing attention to nests for just the couple of hours I put them out at night. So I don't think we have a good handle on what the predators are for the species, but.
Right. Cool. I can add a little bit of perspective to that because I did some research on that. Well, not research. I did some mapping on that a while back, and the big north one is up in Maine. It's the Scarborough Marsh, but you start getting into competition with Nelson sparrow there, and there is some hybridization. Even though the species are so different in their behavior, they do hybridize. There are a couple of marshes in Massachusetts that are really key, including a few just south of Boston. There's like the North and South River. There's a couple of complexes on the upper arm of the cape, if you will, on the biceps of the cape. Then Rhode Island's actually kind of poor in Saltmarsh Sparrow habitat. Connecticut is fairly rich. The south shore of Long Island is gold. And anywhere you get these barrier beaches with the miles and miles of salt marsh, and that's why the south shore of Long Island, particularly the western half of it, is so valuable. And then, of course, as Sam mentioned, New Jersey is just absolutely critical. Probably has more of this species than all the other states combined, I would have to guess, if I had to guess. And then the other one that's really key is Blackwater in Maryland. There are a few Maryland marshes and marshes along the Chesapeake that are very important for salt marsh sparrows. But our top 3 or 4 sites are up there as globally important sites. East River, Hamo, even Westbrook is a global important site. Barn Island is an important site, and then Great Island.
Fantastic. Well, that's the end of the questions. So we've gone just a little bit more than an hour. Maybe time for a wrap up, Patrick?
Yeah, that's about all we have time for this afternoon. As a reminder, you can find Sam's article in the 2020 Connecticut State of the Birds report. We also have relevant articles in the 2019 State of the Birds on sea level rise in the state's high tidal marshes by Min Wong and David Kozak, and on Saltmarsh Sparrows by Chris Elphick in the 2016 report. And our latest report also talks about a lot of species that are at risk from a variety of factors, including sea level rise and climate change. Visit ConnecticutAudubon.org and look for the conservation drop-down menu, then choose State of the Birds. Thank you all for being a part of the presentation and for supporting Connecticut Audubon's conservation work. Habitat protection and climate change mitigation are ongoing projects, and we will be able to accomplish even more because of your support. Don't forget the 3 other presentations on young, gifted, and wild about birds. If you haven't signed up, you can do so at ctaudubon.org/YGW. And of course, thank you to soon-to-be Dr. Sam Apgar. Your work is fascinating and important, and we look forward to being able to refer to you soon officially as Dr. Sam Apgar. Thank you all for everything you do for Connecticut Audubon Society and for the birds. We have a lot of exciting stuff going on, and you hear me often say, we did this, we did that, we did that. Well, you're included in that and I think over the next year, we're going to be seeing some really exciting projects where we're going to be saying, we helped to do this. Well, remember, that's you too. Thank you so much for allowing us to do the great work we're able to do.
Thanks so much for having me. This was really great.
Oh, thank you, Sam.